cooling. So decade by decade, as you see that number of publications in the reputed journals constantly go on ameliorating, and so far we can say that there is a bright future for the subject, as it covering the wide readership, not only to the built environment but also to the chemical engineering, some architectural as well as a building point of view and its concept. So prior to discuss about the desiccant cooling, we may go through the concept of air conditioning. A layman have the basic idea about air conditioning is only to have the cooling of air. But air conditioning is not only concerns to the cooling, but it relates to the simultaneous control of temperature as well as humidity, its cleanliness, and its velocity too. So this brought them related as a thermal comfort. It is the condition of a mind that expresses the satisfaction with the thermal environment. It creates the environment in which human beings can be have a good with regarding to its surroundings. So there are many parameters that can affect the thermal comfort experienced by the human being, that is meteorological, physiological, psychological, clothing, etc. So the term this thermal comfort is not easily quantifiable. So different standards to be followed by the manufacturers in the field of HVAC, heating, ventilation, and refrigeration engineers used to be ameliorating day by day. So here we have given the comparison for the SRA standard 62 to be given out in very early 1981 to 2001. So various applications such as like hotel room, auditorial, meeting room, and office building, you may see that the standard suggested later on in the decade 21st century may be far away with some percentage increase like 200 to 400 as per the varying application. This is due to that as the time may pass, outside and outdoor ambient will become very harsh. It will have in greater percentage of carbon dioxide as well as you can say a temperature because of the phenomena of global warming. So earlier concept provided by the air conditioning engineers for the built atmosphere and thermal cooling will be evaporative cooling. In evaporative cooling, we get cooling of air by pouring some water by passing through some nozzles and get its disintegrate into teeny water particles. So thermodynamically, as this process is endothermic process requires certain heat from its surrounding to evaporate water to vapor, and so far its surrounding getting cool, and so air available from the evaporative cooling is slightly colder than its surrounding air. But there are one limitations with regarding to working of evaporative cooling. It works well in the environment whenever ambient humidity is low, but when ambient humidity increases based on environmental situation or seasonal condition changes or by the location. As you compare certain locations available on a seashore like Chennai, Thiruvananthapuram or Bombay, like where you find always the humidity of ambient air is nearly about 80-85%. So at that case, evaporative cooling greatly works in a great efficiency whenever ambient humidity is slightly lower. So here a climatic applicability as well as seasonal climatic applicability is one of the limitations for the full-fledged working with the evaporative cooling. So far there is a development of another vapor compression based air conditioning. But in case of vapor compression based air conditioning, we may see that most of time humidity is to be removed by maintaining the temperature below its dew point. Dew point is the state of air at which moisture in air automatically get removed by starting the condensation process. So most of time we may see that humid winter, some of the leaves of grass can be pointed out with some little dew. So that is how the humidity is removed from the air. And in this way, we may try to do air in a drier condition. But the process of maintaining very low temperature most of time will result to overcooling, so that it not meet the standard of supplying air to the conditions room. So that you may require to reheat this air to meet the supply condition. And most of time this reheating is excess waste of energy, but it is necessary that you maintain low temperature to remove the humidity. So ultimately this process does not make the sustainable use of energy. You can throw certain energy for the cooling and again aiding the same for the process of reheating to maintaining the supply temperature, and this process decreases the COP of cycle. So this blue line in the psychrometric chart shows you how you can produce air conditioning in a conventional way by the vapor compression, what almost all types of split air conditioning nowadays do. First of all, you will decreases the temperature by reducing the dry bulb temperature of air, then get the removal of moisture by cooling it near to a dew point, and again reheating the same to meet the supply conditions. But this conventional way, especially in the split AC, we are not providing any fresh air. So only fresh air availability may be by the door opening or just partial 5% window you may have to kept it open, so that you may require availability of oxygen for the hygienic condition. Otherwise, if you're working in a split AC more than 10 hours without opening door and window with 100% ceiling, your energy cost may be low, but this will make you starvation for the oxygen and resulted to some serious hygienic loss. So, as per a layman, air conditioning can be done only by controlling the temperature. But by the definition of SRA, American Society for Heating, Refrigerating, and Air Conditioning Engineers, you cannot control temperature alone for to obtain a best air conditioning. You may also control RH. Most of time when you control temperature, but if RH is not controlled, then that effect of temperature is null and void with considered higher RH. So there are different methods available for controlling the relative humidity, that is by heating. If you heat air at its constant dry bulb temperature, constant humidity ratio, that will decreases the relative humidity. Or either you condense the moisture by decreasing the temperature of moisture to its dew point, automatically moisture separates out by condensing in form of water. Most of time you may have experienced the way whenever you go to ATM for drawing the money, most of wetted area will be available due to faulty drain pipe. So from where this water available? This water is available as it separates out moisture in form of condensation. So by the surface maintaining its temperature to your dew point, moist air surrounding to that surface will try to condense out in a droplet form and will be separating out in form of water. So if its temperature be maintained below the ice formation temperature, instead of forming water droplets, it's converted directly into the ice form. So there are chilled water systems. Suppose you may have a 200 outlet in some 5-star hotel. So it is not feasible to supply refrigerant through a long pipeline of, you can say, 100 feet, 200 feet, or in some meters range. That it increases the cost of pumping. But instead, we may have to provide a chilled water system, chilled water having its temperature around 3 to 5 degrees to be pumped in a better way through each individual outlet. So with the diagram shows here, how can show the energy and temperature while carrying a colder or chiller water to the longer distance. So this type of principles used basically in industry is called the THIC, separate humidity control from the temperature control. And some books are available in the market to explain that principle in very well in detail as well in experimental way. So there are certain benefits of this kind of system. So most of the air conditioning system can be coupled and integrated to the renewable solar energy. So when solar energy at its intensive phase, also we may demanded higher air conditioning power or cooling power. So that different solar cooling technologies can get compared here like absorption, adsorption, desiccant cooling, and ejector. Out of comparison among the all, you may see coefficient of performance in case of desiccant cooling will be optimum among as far as maintenance of regeneration temperature for the different application. So why we need to change the current available system? Because in automobile, you may currently see most of the fossil fuel based internal combustion engines can get replaced within next 5 to 10 years with the electrical vehicles because of the environmental problems. As far as the cost of petroleum uh, concerns to India. Okay. So here in air conditioning also, we may have to consume a lot more power of a high grade electrical power in the thermal station for running the AC. And still it not do with regarding to air quality or maintaining the necessary humidity. So most of the buildings are uncomfortable when we go for the 60 plus humidity. It is the one of the rigorous humid load provided to air conditioning can be reduced in a better way with the desiccant cooling. So there are certain problems that can be available with the use of current HVAC, vapor compression based HVAC. It consumes 40% of total building energy for its running and operation. It cannot effectively control humidity. Why effectively not control humidity? But because it require a very low temperature around dew point and require irreversible heating for overcooling problem. So that it is not economical too. Health and comfort suffer a lot because it cannot provide you a large amount of fresh air. Its first cost is too high as it has to work at some parts very high temperature and pressure, while other parts to pressure and temperature less than the ambient. Ventilation load at peak time cannot be made, and indoor air quality suffers great with the conventional HVAC. So overcooling and reheating is an unsustainable use of energy. So we are in a state to change or to replace or to provide alternative cooling technology because of this kind of problems discussed. Comfortable conditions defined by SRA is to maintain around 78 to 80 degree Fahrenheit temperature as well as around 50% RH. So one question born into the mind of you, why we have to maintain 50% RH? So I will have to show you one diagram. This is the diagram in which ordinate will give you different respiratory infectants, okay, like bacteria, viruses, fungi, and chemical interactions different in the industry. And abscissa or horizontal axis will give you the different percentage of changes in the humidity to be start from origin 0% to 100%. So you may see there, whatever may be the infectants, some areas will show a very dark. That dark area will be from starting 0% humidity to around 40-50% humidity. Again, when you cross 6-7% humidity to meet it to 90-95, again it got intensifies. So here color code will be in terms of a dark red areas. Only a small area in a peculiar range of 40 around 50% RH, it shows lighter area or just a contrast. Okay, this represent in a better way this diagram. Around 50% humidity, chances of infectant interactions and inborn different bacteria to be spread will be minimum around 50%. And that is the reason why we have to maintain around 50% humidity in indoor conditions, so as the infectants can grow in a minimum way or to have a spread in a minimum way. Dehumidification can be done, as I explained you earlier, with the chilled water by using the secondary refrigerant for the low temperature applications like chilled brine, direct expansion kinds of system by maintaining handling of sensible and latent heat load separately. So we have the principle of vapor compression system in which basically the circuit used connecting evaporator, compressor, expansion valve, as well as the condenser. But as this principle is already been taught you at undergraduate level, we may have not discussed much detailed part of this. So day by day, as you go, earth temperature may slightly go on increasing due to hot summer. Day by day, reducing the plantation on the earth as well as use of more industrialization. So whatever may be the purchase and demand of AC will increasing as shown here in this graph decade by decade. So that is still increasing the cooling demand by a global warming, because it expelling out the inner heat to outdoor environment. So outdoor environment decade by decade will become warmer and warmer. So one nub of problem is that we might have to go through the system that may not increases the global warming phenomena or can be resulted to the better carbon saving. So how our ordinary or a conventional system can compare to the desiccant cooling system? First of all, we may have to go through conventional cooling, vapor compression based, such as like what a split AC you are using currently. Ambient air, according to kind of system, whether it is open or closed, air is to be taken whether from room or from ambient. Okay, so it may get first it cooling and dehumidification or drying in a cooling coil by maintaining its temperature very low, around 4 to 5 degrees, so that moisture will be drained out by condensing the humidity in form of water, and the air can get dried and its humidity to be maintained as explained earlier around 50%. Then it require insertion of heating coil. Heating coil is necessary that it maintain the supply temperature. Otherwise, you have to send overcooled air, and it not meant for the air conditioning. My voice is audible, sir? Hello.
Yes, sir. It is audible.
Okay. Intermittently, I can ask a question because internet connection or anything can be interrupted in between. So that please.
Okay, sir. No problem.
Yes, yes. So at the state point through shown here, air is inducted to the air conditioning test room for the purpose of comfort cooling. And the same process I have shown here on the psychrometric chart. Process 1 to 2 is the cooling and dehumidification, and 2 to 3 that will be heating. So here we may have unnecessarily waste the energy in overcooling to very low temperature, 4 or 5 degrees, and again heat it to meet the supply conditions like 15 to 17 degrees. But if instead we have splitting up this cooling and dehumidification operation into the different components, then we have the feasibility that we may have interrupt the operation of individual components among the kind of temperature or humidity availability. So the purpose cooling coil is replaced by a dehumidifier as well as a small cooling coil. Sorry. So here dehumidifier is one of the rotary wheel. Okay. So air has to pass through it, and according to the Dalton's law, partial pressure when air is laden with moisture, its partial pressure will be very high, and partial pressure for the desiccant material is very low. So by the pressure difference, moisture contained in the air can get traveled to the desiccant wheel provided. Okay, and so air will become drier. Then it will send to the cooling coil. If the temperature load is not that much, then cooling coil may be of evaporative kinds of thing. But if it will be sometime require large cooling load, sensible load, at that time you may have replaced it with the vapor compression unit, but it is the downsized unit. Whatever may be, suppose 5 TR unit to be used in the conventional system, here in desiccant cooling, it requires only just 0.5 or 1 TR unit. But after dehumidifying the air by passing through the dehumidifier, it gets saturated. So its effectiveness on its periods of service will be reduced. So as to maintain effectiveness, it requires wheel to be regenerated. So we may have passed certain air here shown is called the regenerated air to be taken either from atmosphere or from the room, and the same can heated to meet the dissolving temperature of the desiccant used in the dehumidifier, and then it will expel into the atmosphere, exhausted to the atmosphere. Similar process shown here on psychrometric chart. It is reversed but what we observe in the conventional system. Process 1 to 2 is isenthalpic, in which only humidity can be reached, but at the same time temperature may be increased because of adding the condensation heat to the air to be dried. And at a 2-3, it increases the cooling, means that you decreases the temperature. So here the process of dehumidification as well as cooling can be splitted up into two components, not in a single component. Here single component cooling coil, but here dehumidification can be occurred with the dehumidifier and only simply cooling to very high temperature around 16-17 degree, so as to adjust it according to supply conditions at the state point 2. So there is a requirement of heating coil is to be omitted, as well as if your requirement for dehumidification is achieved, dehumidifier will be put off its operation. And if your demand for cooling is available, it will put cooling coil to be off and only dehumidifier working. But here in conventional system, any of the criteria will be with regarding to temperature or humidity achievement, but you have to still working it to that much low temperature. So here sustainable operation and working can be possible for the energy saving for the alternate criteria to be met. And this is as we have to split it the total operation into the separate components. But one of the major disadvantage of this system that you may have to provide regeneration here because of disrupting the wheel, regenerating the wheel. But nowadays you need not to supply electrical energy or high grade electrical energy. Instead that you may have to provide certain low waste heat in the industry as well as solar power. So that may save the energy by the desiccant cooling further to a high value. And here, as far as the process flow air rate, which is 3/4 of the 1/4 reactivation air supply, so that it require greater mixing of ambient air to provide a better ventilating conditions. So for the cost of cooling is slightly lower here. You may have got mixed the outdoor ambient air, sometimes may be enriched in oxygen, so that it maintains proper indoor air quality. So which are the benefits of using this innovative cooling? It is environment friendliness. Most of time in low humid conditions, you may not require certain vapor compression system. It can be okay with the use of evaporative cooling as far as cooling load is concerned, because you don't have any dehumidification load. It already get controlled in a previous component called the dehumidifier. It saves around 25% of the total energy to be used in the conventional system if vapor compression can integrate it to the dehumidifier. Maybe the source of reactivation energy may be diverse as a solar, waste heat, or either natural gas kinds of thing, which may not be as much as polluted as compared to the fossil fuel based. Indoor air quality can get improved due to higher ventilation rates and capability of desiccant to remove the airball pollutants. Because what happened, moisture separating outward to the desiccant surface, some of the infectants can also do. And in the reactivation air, as it passes, will evaporate the moisture. And so for certain impurities and infectants also get traveled to the exhaust along with the flow of reactivation air. The operation of valve process is nearly to the ambient as it requires only fan power most of cases, otherwise minimum compression power with the use of compression and electric motor combo. So maintenance is also simple. Desiccant cooling can be alternately used according to seasonal variations in summer or a monsoon as far as winter with the different configuration. So due to separate control, it has a better control over temperature and humidity. It may provide you large ventilation airflow to provide and to maintain fresh air. Use of solar or waste heat can be used for reactivation purpose. It can judiciously be coupled to the cogeneration system in the industry where you go for combined power and heat generation. Downsize the size of the sensible cooling unit as it has to handle sensible heat load and its operation is at ambient pressure. So there is no problem of leakage as far as the cost of component is also cheaper. So desiccant cooling at a time can be a combination of a clean energy, clean technology as far as clean environment. So there are different types of desiccant cooling used in the HVAC or inbuilt cooling. That is solid desiccant material, liquid desiccant cooling system, or hybrid desiccant. That is as per the property of the different desiccant material used. And as for application, it may be used in different industries as far as the different geography of the world concerned. So desiccant dehumidification care for reducing the RH, relative humidity, by reducing the moisture content. As far as humidor is passed to the desiccant surface, it has a higher pressure. Desiccant surface has a lower pressure, so that it reduces the moisture by attracting and get it condensed out over to the desiccant surface. So only dry air will be available to carry travel. So desiccant cooling nothing to do. It has to change the dehumidification or latent heat load into its successive sensible heat part load, which is easier to handle. Different types of desiccant materials are used. So chemical substance which has the capability to absorb moisture by the natural affinity is or are called the desiccant material. All materials available in the nature were not desiccant material. You may require inherent capability for abstracting out moisture, is called the desiccant. So whether the this kind of material available in a solid state or liquid state may be classified into solid desiccant or liquid desiccant. So silica gel, synthetic polymer, activated carbon are the types of solid desiccant, while triethylene glycol, lithium chloride, calcium chloride, etc. are working as a liquid desiccant. So solid desiccant by its nature is called the adsorption. Only the moisture can took part to the surface, while liquid desiccant adsorption is called the absorption process. While water molecules can take part to the structure of the desiccant material used or absorbing out the same. So which are the characteristics or ideal properties for the material to be required to behave it as a desiccant material? It should have a very low surface vapor pressure under its dry condition. Means when desiccant is dry, its surface pressure is very low, so that it can attract the moisture available in moisture at a higher surface pressure. And it have the moisture capability to abstract to very high range, around 10,000% to diode, and should have the low heat capacity. So basic working principle of this desiccant cooling, that you may have to provide pass the process air through the process area air section of the dehumidifier, which is moisture laden or highly humid. By contacting to the desiccant, moisture is removed and only dry air is allowed to carry to the cooler and conditioned air to provide the room. Now by working, desiccant material abstracting out moisture will become saturated. So if you using the same again and again through the cycle, will not provide you the necessary effectiveness. So yet you require refresh, regenerate the dehumidifier by removing the laden moisture. So you may have to provide a hot air to be available by the regenerator components, and it may rise around 80 degree or 100 degree centigrade to the air available, and that is air having very low vapor pressure as compared to the saturated desiccant material surface. And so far it exhausts out moisture back to the hot air in a reversible way to make the wheel dry, just as like how can we dry our wetted clothes in open atmosphere, so that the wheel is again get its regenerative condition and can abstract the moisture by available in contact with the processor. So how the liquid desiccant cooling work? The working schematic shown here. First of all, you may have to pass a return room air or a room air simply at the bottom of the absorber column. From the top of the absorber column, desiccant material in its liquid conditions pour it. So by nature, desiccant having absorptive or attractive nature for the moisture contained in air. So at the bottom, by providing the drying to the air, desiccant will abstract out the moisture, and from strong condition at the top of the tower to the weak condition or a diluted solution will be available at the bottom of the tire. So rest of the dry air is made to dehumidify it again to the room. And now if same solution used again and again, then it will decrease the effectiveness of operation as it got saturated. So you may have to regenerate the same. So you may have passed this weak solution again through the another column that is called reactivation column, regeneration column. So here a weak solution is to be poured from the top, and from the bottom scavenging air, reactivation air may pass, which have a very high temperature, so that it get absorbed the moisture from this weak solution. And at the bottom of the tower, you may find after losing moisture, strong solution, and then it will again sent to the absorbent column, and rest of the scavenged air may exhaust it to the open atmosphere. To maintain proper effectiveness of heat transfer, alternately we may provide cooler and heater in between the absorber and regenerative column. But there are certain limitations of this liquid desiccant cooling, that certain corrosive problem is there, because it has to work into the liquid diastate condition, and certain carryover, some fumes of desiccant always be carried to the occupant. So this kind of system is mostly used for the industrialized purpose, not for the human conditioning. And crystallization, whenever drop the temperature of desiccant material got converted into the crystalline form. So this again, how can we explain the principle? This is the pictorial view of the different kinds of desiccant used. Whenever you brought a new electronic item like mobile phone or your computer, laptop, etc., you may have find certain globules of silica gel in a packet form available, that it maintain dry conditions so as to save the circuit of your laptop or computer or your mobile. So similar, how can we compare the performance of different desiccant material like silica gel, clay, molecular sieve, calcium, etc., so that this performance group. Similarly, this way we may also compare Kerfoot's law. Basically, in the structure of dehumidifier, overall area of airflow itself separating out, splitting out into two area section. One is a processor section, another one is reactivation air section. And each alternate airflow, process air or reactivation air may not allow to flow or cross each area section. Am I audible, sir?
Yes, sir, you are audible.
Okay, sorry for the interruption, but for making sure about connectivity, I will have to interrupt it in between 5-10 minutes. Okay, so here you may see that in a process area section is just 75% of total wheel area of the process airflow, and reactivation air is of only 25 to 30%. What will be the temperature of process air may flow, which is of ambient air or mixture of ambient air or room air, which will be available to you at a temperature range, you can say around 35 to 30 degrees centigrade, while reactivation air may be passing through the reactivation window at a very high temperature, 100 or 80 degree. That is the suitable requirement for the desorption of a desiccant material used. So this how the process represented onto the psychrometric chart. So by the time constraint, I will have to get past to certain slide without much discussion. So here one of the another wheel added to the schematics present is called a rotary sensible wheel. What happened most of time at a state point 2 shown in the diagram will convert its form from latent to sensible heat, as I explained you earlier, so that it aids certain heat after desorpting out moisture. So we may require to reduce its temperature by certain air to air heat recovery wheel. So it will given out alternately way to the state point 6 to 7 flow of air in a reactivation temperature, so that this rotary sensible wheel can increase the performance of the cycle in terms of exchanging heat between process air and reactivation air. Because in process air at a state point 3, our demand is low temperature dry air, so that that heat is available to the demand of 0.7 high temperature air. So alternately, this will increase the effectiveness and performance of the cycle depending upon the different configuration for making air available to the flow to the system or to the supply. We may have a Pennington cycle is called open cooling cycle. From ambient at a state point 1, we may have to take an air, and recirculation cycle at the bottom, we may have to provide return room air. That determines the availability of ambient. There are some questions available in between, but I can solve it later at the end by completing my discussion. So this is how ventilation cycle work. You may have to take an air to the ambient, and at the end, you may have exhaust out the same to the ambient. Recirculation cycle, maybe some air from ambient may get mixes with the return room air, and its comparison will show that certain benefits with the open cycle, you can say, or ventilation cycle, which demanded low regeneration temperature, but certain benefits with the recirculation cycle, that minimum availability of temperature maintenance at a process section. So Dunkel cycle, providing more than one sensible heat so as to exchange it in a better way to ameliorate the performance of the system. Some Dink cycle, in which we may have combined both the type of evaporative cooler or direct evaporative and indirect evaporative cooler. And there is a mix of test room return air also in combination with the fresh air provided from the process section. In sense cycle, we may provide different split incubation of providing the air to the dehumidifier as well as exhausting out to the sensible heat recovery wheel. So this graph will show you the comparison of various cycles, which will be better on in based on the given conditions of supply air or regeneration air. So desiccant cooling cycle is basically dry the air by contacting the humid air by passing through the dehumidifier due to variation of pressure between desiccant and air made the flow of moisture from humid air to the dry desiccant. So sometimes it is called 100% recirculation system, in which you find 100% of return room air may got recirculated through the intake of the desiccant wheels. Sometimes you may have percentage mixing. Air coming from outside partially get mixed, you can say 10%, 20% in the range. And some that much mixed air to maintain airflow may have bypassed the dehumidifier partially. And sometimes you may require pre-cooling of the ambient process air to keep it down its temperature. Sometimes it may require post cooling to make a supply conditions. Sometimes in the both the way, pre-cooling and post cooling operations will be required. So this is how schematically it works. This will give you the idea about the mathematical quantities to be presented at different state point. Suppose you have the temperature of air at the inlet of desiccant 32 degree. After passing through desiccant, it will increases around 50 because of addition of latent heat of condensation from the moisture being condensed on the surface of desiccant because of partial pressure variation between dry desiccant surface and humid air, which is very high vapor pressure. So again, it has to pass through heat recovery, may drop down its temperature to 24 degree. And at the end, we may have to supply to 16, 17 degree conditions of air supply. And in similar way, you may have find the change in the relative humidity to the supply too. And similar way, you may have different observations on the reactivation air part. So sometimes we may have used diversified sources for making reactivation of dehumidifier. So sometimes we may use a condenser heat, which is sufficient to meet the reactivation of the dehumidifier as shown here in this diagram. Sometimes we can make use of solar energy so that solar collectors can be collecting solar power for heating the water, and that water by passing through the liquid to air heating coil can use to maintain the necessary dissolving temperature for the kind of desiccant material used in the dehumidifier. Sometimes industry having its own generator or a diesel generator set. At that time, exhaust of IC engine may be available around 200 to 300 degrees centigrade. So that exhaust may aiding to heat the air at the reactivation airline will used for conservation of energy. Similarly, solar power may use it for. This will give you a list of different industry where you can get different sets of heat exchangers, how much humidity drop to be occur, and possible range of reactivation temperature to be available in the byproduct of the same. So whether we compare a dedicated vapor compression cycle plus desiccant cooling, and if we couple it further to the vapor compression, desiccant and evaporative cooling, so we find in the last case, hybrid case, COP may be above 4. That will give you the best energy conservation. So how desiccant will look like? It is the wheel having its internal matrix to be made of some metallic material like aluminum, having certain fluids, and internally that fluids is impregnated with the desiccant surface as shown here, through which air has to pass. And while air is passing through that surface area of air can exposed from all sides with the dry desiccant. Dry desiccant will abstracting out moisture so that the air will become dry at the other end. So this is shown in the psychrometric chart too. Various applications in supermarket, theaters, hospital, hotels, where large area to be cooled and get dehumidifier. In office, pharmaceutical plant, this is why it is not suitable to the smaller applications, such as like absorption cooling. It is used only when we have the huge requirement. For our ordinary system of a one office having sitting of 2 to 3%, this kind of system is not feasible. Our conventional system may do better in that way. But when area will be increases, or some case in pharmaceutical plant, maintenance of humidity is very low, around 2 to 3 gram per water vapor per kg of air. At that time, this desiccant cooling play a big role. So it is a hybrid cooling. Whenever you couple desiccant dehumidification with the conventional cooling system. So there are different manufacturers available in the India for the desiccant wheel as per the availability and application type for the selection of material and their sizes. So the simulation will show you how the dehumidifier can get working. Just a minute, I will. First of all, wet process air is allowed to flow through the process area air section of the dehumidifier, so that after dissolving and removing and relieving the moisture, dry process air may be taken out, can be used for the further cooling prior to supply to the room. And reactivation air on the opposite side may have to pass to the electric heater, so that it can get regenerate the dehumidifier by maintaining temperature around 80 to 100 centigrade, and rest of moisture is exhausted out, and the dry will again may have to pass to flow through the process area air section. So this is how a dehumidifier unit will be looks like. Separately sealed containers provided for carrying the air through the process air section as well as the reactivation air section. Certain belt and motor drive mechanism is provided to rotate the wheel at very slow RPM, and that RPM may be 20 RPH revolution per hour. That is to permit the dehumidifier with any mixing, non-mixing. That is how the fluids are look like in the real operations in the desiccant wheel. Size of the desiccant may vary according to application and kinds of dehumidification rate you maintain. Maybe the size of dehumidifier as shown here above the height of a average human being. So how the reactivation air temperature play a role with regarding to reducing the humidity. This is how a hybrid desiccant cooling, coupling of vapor compression to the conventional desiccant cooling will get working. The simulation diagram, but later on I may type the simulation. First of all, there are three kinds of colors and its arrow coding may be provided in the diagram. Blue color will show you the flow of process air. Red colored section arrow will show you the flow of reactivation air, regeneration air flow. And black color will show you the flow of refrigerant in the typical conventional vapor compression circuit. Now the system is got simulated as you see the working. First of all, at state point 1, return room air initially passed to the dehumidifier for drying. At state point 2, it further passed to recovery wheel for the cooling at a sensible way, and then it passed to the vapor compression cooling coil, evaporative cooling coil between state point 3 and 4, that it maintain the necessary cooling rate and prior to supply to the return room air in a conditioned way. So reversibly, ambient air may in a red color arrow at the top at state point 6 may be taken in, and it got partially heated, and finally temperature achieved by passing through the electric heater at a state point 8. Then it got dissolved the moisture and exhausted to the atmosphere. Rest of the back color will show the flow of refrigerant through the compressor, condenser, expansion valve, and evaporator. So there are different types of instruments used for to measure temperature, humidity, energy, as well as air velocity and flow, air temperature control, thermostat, and some data scanner to with the runtime simulation. Different performance parameters may be used to measure and evaluate system performance in terms of energy consumption and coefficient of performance. So, effectiveness of re-temperature is shown that COP is not constantly increasing with regarding to the comparison of desiccant material, lithium chloride and composite desiccant. It will increases up to 100 degrees. Still further you increase reactivation air temperature, it drastically reduce the COP down. Effect of process airflow, how it can relate to the COP. This RP ratio, reactivation to process area section, how it can get affect the dehumidification rates, how the enthalpy will recovery will get its working. So these are the different benefits of the system application of the different part. Some of the slides are intentionally kept omit for as to meet you only a concern problem. Brief history of desiccant. It is a very early prior 1935. Some concepts are given. Later on, a theoretical cycle suggested by Pennington, and in 1968, Moore Cantor will get a first desiccant dehumidifier, and in world Munter is the big company that will provide desiccant to the world. Jurinac will get it simulated through some tangent system, and Pesaran in 1992 will get inclusion of solar energy for reactivating the desiccant. This shows the important pipeline and different mark and historical inventions in the field of desiccant cooling. There is a different scope for studying this topic, both in experimental way by making the numerical of system tangent system simulation by use of the tangent software, by predicting the result by artificial neural network. You can make the system energy analysis by thermodynamic and exergy analysis. This is the experimental setup. Photos that setup is got made and erected by me at IIT Roorkee during my PhD work around the year 2012 to 15. This is the room for which I have made calculation for the cooling load and its technique and to meet the design comfort conditions. Different uncertainty analysis can also be performed to measure the uncertainties in the measurement of temperature, pressure, flow, etc. These are the summary of different previous research work done by the different researchers across the globe with regarding to desiccant material, its size, speed, volume, flow, process air, reactivation air, and its coefficient of performance. Methylene modeling can be performed for the dehumidifier. You can simulate the system by using some transient simulation software. This is shows the model of studio project made by me to simulate the system experimental tested at IIT Roorkee. This shows the simulation result for the cooling period from March to September with regarding to changes in the different temperature at a various state point as well as the humidity ratio. Model for artificial neural network for predicting the system performance for getting the different output for the suggested target level, and it's a model for that. And another exergy analysis is performed for to know the energy performance of the system by knowing the exergy destructions at the different component. The system is compared against different currently used HVAC system and comparable performance may be achieved. So by comparison, at the end, we may conclude that desiccant cooling will give you a suggestion of materials, desiccant materials, which regenerated at a low temperature, so that air quality can be brought up and it removes any pollutants and contaminants and make it environmental friendly. So at the time when desiccant cooling can bring the amelioration of comfort, energy, and cost saving to the environment. Different reference books are available for the further study of the system, and I'm very thankful as you have passionately listened me for the rest 60 minutes time for understanding this new topic. Anyone having any question? Just 1 minute. I will have stopped my screen sharing. Now, one by one, first I solve the query to be presented in the chat box. Professor Langanthan Viramultu wanted to know why silica gel exhibits blue color. Meanwhile, packing contains silica gel is a transparent. So, silica gel mostly available in blue color, but for to get it compare on the different color scale, maybe certain additives may be added. How do we maintain 50% RH without air conditioning? And is there any simple method that we can adapt in real time? To maintain the humidity, we may have a option of removing the moisture by cooling to the dew point by condensation in ordinary cooling. And in dehumidification of desiccant material, we may have a principle of change of partial pressure between desiccant material under its dye condition as well as the humid air having very high humidity, having high vapor pressure. So air itself loses its humidity to travel from very high pressure to low pressure. And that's why the desiccant having the affinity to attract more and more moisture. And at the end, after abstracting out moisture, desiccant itself get saturated. So this is how the humidity is to be maintained. Another way we have to reduce the humidity by the process of heating. All options I have to go through in earlier side sections of my discussion. Thank you, Kiran sir, as well as his team for to provide